Hello everyone, welcome back to the Avalon Game Project. So since last time I have refactored the services and the entities, made a couple of changes, nothing too much to worry about, just renamed a couple of things, cleaned up a few some logic. But what's important is that all the unit tests are rewritten, so we are good to go. So with the game core being implemented, the next step is to actually making the implementation. So remember what we're saying is that the game core only cares about the core game logic, which is how to handle the actions from the players and how do we distribute the events to the players. Persists what's going on and distribute the events to the players. So at this moment, so in the game core, we don't want to worry about how are we going to save to persist the all this data, and how do we communicate about these events to the players. We only want to take care of the core logic, so that no matter where do we deploy this piece of logic, if there's no bug or no changes to the game logic, this package stays the same forever. By taking communication service and repository as a dependency, so that the game core logic itself doesn't really only provide an interface to actually here I have to add something as well. So here we only care about the interface of these two of the communication service and the repository. Okay, I think I have made a few mistakes, but let me fix this. Okay, same as here. Right, do we have anything else? Yes, this is done. This is done already. Do we have anything else? Yep, cool. So, sorry. No matter which, let's say, take a repository as an example. We do need all these methods to be implemented, but the implementation may be different if we decide to use, say, MySQL or DynamoDB. So, and the good part is the game core logic doesn't really care which database we use. It's an implementation detail. So we're just going to provide this interface and allow whoever uses this game core to implement their repository and pass it to the state machine, so that we could just run it. So with that being said, I have started to implement the repository. Okay, so let me see, game event player, where is the player? Put player, get player. Okay. Okay, so with that being said, so remember in the beginning of the I think in the first or the second episode, I have explained that I think I have decided to go to deploy this on DynamoDB and deploy this on AWS Lambda, so that when we don't use it, we don't have to pay for anything. So I will have a DynamoDB repository implementation. So I have started to implement this, and I have finished the very first method, which is the get game. So I'll quickly explain this. So DynamoDB, it requires so it's so DynamoDB encourage users to put everything in a single table. So basically, you can have multiple columns as long as so you can put like different things in the same table. So for example, we can put a game and a player in the same table. Even though for game we have like status, state config, and player IDs, but in the same table we could have players with, say, player name and player ID, things like that. So this is very different from relational database, and some people may wonder, like, how does that work? How do you find things? So the trick is, well, not really a trick, but the recommended way is you basically use a combination of a primary key, also known as hash key, and a sort key combination to find your stuff. So in this case, for game, we'll have so for this project, every item, every entity of a game will have the same primary key, so the game ID. So as long as we use the game ID, we can find everything related to the same game. Then we can deal with it. But we can use the sort key to add more information. For example, the sort key of a game entity, which is 1 per game, is just the word game. So for player, their sort key may be the player's unique ID. So with the combination, we know that, okay, so use the game ID, which is unique per game, and the player ID, which is unique per player, will be able to find a player of a game. The same theory applies to event, action, quests, round as well. Though for round and quest, we'll have more information in the sort key. For example, we want to have the quest number. The for quest we want to have the quest number. For round we want to have the round number so that it can be sorted. But we'll talk about that later. But anyways, so here we will so here we this is our implementation. So we have a table. We initialize the DynamoDB. We use the resource to actually find the table. In the table, we are using the primary key and sort key to find a to get a response, and the item of this response is the game entity itself. And in the repository, we are going so the repository is responsible for creating a entity provided by the game core, because again each database have different implementation. One example being, as you can see here, the quest team size is a int to int map or dictionary in Python. But the thing is, DynamoDB uses decimal to store numeric values to keep its precision. So for us to be able to construct a proper game config entity, we'll have to cast the key and value from the database response to int implicitly, explicitly here. So this is one example of the details we want to worry about. Okay, so with that being said, we are going to implement the next part of the next method. Okay, before doing that, again, this project, one last thing I promise. This project, I mentioned from the very beginning, we want to use a TDD approach, which is test-driven design. So I have already created a test, not unit test really, but a actual test. Because the thing is, repository is responsible for talking to the database and unit testing it. So here is a bunch of getting and settings. In my opinion, unit test it doesn't really help that much, because the unit test can, like, our logic can be perfect, but still it won't really match what's getting from it doesn't matter if, like, we're not mimicking the real stuff. So what I'm doing here is to actually bring up a Docker container, so basically a local DynamoDB, and to actually interact with it here. So I can show you that if we run this test. What is going on? Make a request. Oh, I don't have Docker open. Oh, sorry. So okay, so this is one of the things. It assumes that the Docker is running on the host. So now I have the Docker opened. So if we run this, we actually bring up and Docker. Okay. So this is the two method okay. Let's see. Put events. Okay, I'll comment this out for now. And to do these two, I don't really want to leave it because this is just a wrapper method of the actual put player and what was the last one? The put and put events. So I'll remove it later, but for now I'll just comment it out. But back to what we're doing. So when we run this test, we will actually bring up a Docker instance here, a DynamoDB Docker instance, and we are going to connect to it. Once we connect to it, we are going to create a table with a primary key and a sort key. Both are string type. Well, these are just default value. We don't really care about it. We wait until the table exists, then we basically return the DynamoDB client. And in the test itself, we use the client to actually store an item. As you can see, it's rather complicated. So it's gonna be a lot of work. But the thing is, then we use the real database to really find the game and verify if the game entity we get have the correct values. So this might seem a bit tedious, but in my opinion, this is really the best way of verifying if we are implementing these, we're really implementing these things properly. Okay, so actually this is the good start, because now we have a get game. This is querying from the database, which we actually store something using the DynamoDB grammar, and then basically transform it to the game core entity. But here we'll have to actually insert something in the table. So yeah, I think let's implement this. Okay, so here we have item equals to primary key, of course, is the so here, even though we're not giving this event IDs, we still want to have an ID. So I will event ID equals to UID. Okay. So here event ID. So in this way, we could easily query all the events basically of a game. all we have to do is basically doing like query primary key equals to game ID, and the sort key starts with event underscore. So yeah. I think it is a good idea to basically include timestamp. Nah, it's fine. I'm not gonna do that. We could sort that later. So the event type is event type. Recipients is recipients. Recipients payload timestamp all good. Then self input integrator. It's fine. Okay, event type. This is also event type. Here we have event type dot value, and then wait, this is just type. Okay. Recipients timestamp. Cool. So this is everything. So let's have a repository and client. So given we have a game ID, we have a actually I want a marker. We'll have to patch the DynamoDB repository so in this case so that it is that why this is formatted for me? Why? Interesting. Anyways, okay, so game ID equals this, a recipient equals to player ID 1, payload equals to key value, key 2, key 3, and key 4. Okay. So now, timestamp. Okay. Oh, this is pretty good. So when event equals game ID. Oh, we need event type. Event type equals to event type dot. Okay, game start is good enough. Okay, game ID, event type, recipient's payload timestamp. Cool. Okay, so with this, then we want to verify that event ID equals to event ID. No, so we want the to get the event ID. So event ID equals event ID. Wait, what? Really? No, I don't think so. Game ID equals event type dot value. Game ID equals game ID. Recipients equals recipients, payload equals payload, and timestamp equals timestamp. Okay, let's run this. Oh, we also want to verify event. Oof. All over again. Sorry, event ID. Game ID, event type, event recipient, type, payload, and timestamp. Okay, let's run this. Okay, so put event type. Oh yeah, okay. Okay, rerun this. Wait, what? Where? Oh no. Okay, I want to take a look at the actual event. Okay. Ugh. Hmm. Apparently, we have to do something like this. Jesus. Why? Okay. So apparently, table is more suitable for it. So I am going to so I'm going to use table instead of a client. Apparently it is very annoying. Okay, let me see table. So we do have table here. Okay. DynamoDB table. Not DynamoDB table. I'm gonna rename it to DynamoDB table is good enough, I guess. Okay, so if we were to use table, this no longer has to be this complicated. So the item could be pk just game ID. Status state config okay. I'm gonna what is going on? Do we have assassination player IDs? Okay. Okay, So we have this, and we have, and the same here. So let's take a look. So is the put item not working? Game ID as, oh, stupid. The only problem with this is it takes a little bit time rerunning everything. Okay. Okay, perfect. Okay, now we can delete this. This is much simpler. So now what we're having here, there's no item. Okay, that's not good. We have put item, let's see. PKSK, nah, same thing. Now we can take a closer look. Oh, of course. Stupid. The the event ID is actually the sk, and it has to be sk dot split underscore 1, because after splitting it, the 0 is event, the second part is the event ID. So we have to do this, and this is not game ID, this is the PK. Primary key is that. Okay, same. I mean, that should be fine. Event doesn't equal to event ID. What? So what is the actual? Oh, this is so stupid. See, this is the problem using fake things. Oh, type. Yay, okay, cool, everything passed. Wonderful. So now we have got player. So it's the same thing. Let's copy paste this one. We still need a game ID because it's PK. Here we have 8 different usages. Okay, so it's fine. So all we have to do is to assume the player ID entity contains the game ID. So player ID equal is actually looks like this: game ID underscore player ID. Yeah, so this is still unique, it's just a bit longer. Okay, so now we have to split. Game ID player ID equals to split Okay. So so when we put player, we'll have to keep this in mind. Okay. So response game ID sk is player ID. Okay, so we'll have to do something like so item, the player ID. So what does player look like? So it has ID and game ID. So the ID we still have. No, the ID is still player ID. Okay, let's not change that. Game ID equals game ID. Name is name, secret is secret, row is row, non-player ID is this, and there's no status. Cool. Let's test it out. Okay, game ID equals this. Player ID equals to okay, the player ID is really okay, this is another Merlin. So the item should be name. Let's give it a secret equals to another UUID. So pk game ID sk equals to game ID. No, sk actually is this. Yeah, this is correct. Row is row. Secret is secret. Okay, no, that's fine. So given, so we put this item in. When we actually get a player, the player ID is a little bit different. So in this case, it is actually the game ID player. So the reason why we need this player is for us to be able to query all the players. So basically we can do pk equals to game ID and sk starts with the player underscore, so that we can easily just verify easily find all the player entities. So here game ID equals to game ID, the player ID actually equals to player ID. Okay, the row is actually no. So we give it a row, but this row is actually no. This is this is actually row. This. This. Equals to row. Yes. And secret equals to secret. Assert player dot non-player IDs. Oh. So same as here. This needs to be a get because this is optional. Both row and the non-player IDs are optional. So that means, well, this actually is different. Do this. So ideally, we want it to be empty list to basically eliminate any for us to not having to do any null checks. I'll just put it there. But row is definitely optional because before the game starting, we do not know the row of a player, so it can be null at some time. So here we can only do this. So we only let only to parse this if we have it, or else we'll just give it a non-value. So here no row, I think equals to a non-player IDs actually equals to a array. So let's test it out. Name. The name is not correct. We're not giving it a name. Oh Lord, with all these things, we forgot to give it a name. Just fabulous. Okay, name equals to player name. You know what? Because, well, as you already guessed, according to my accent, I am a Chinese, and I do plan to play this game with my Chinese friends. And it is almost certain, as certain as tax and death, that they will be putting in their name in Chinese. So I will test the encoding here. So bear with me. Okay. So the name is name, and we want to assert the equals to name. Oh, check it out. Yay! Okay, it even can read Chinese. This is perfect, and this is why I love DynamoDB. It is so. I don't have a better word than soft, flexible. Okay, flexible. It can handle everything out of box, so it's just amazing. Okay, So I think we have done enough today, even though we only have implemented 2 methods, but after this, everything is really simple because all we did was, everything here is just getting and setting. We have, I think, 2 updates, update round and update quest, because we have to create a quest and round first, then update its team members and its status, of course. I will be making changes to the repository offline, and I think the next time we'll have a bit more progress here. Another problem is these tests takes a little bit of time to run. This is not ideal, but I still believe it is worth it to interact with an actual database. The only thing I think I will do is to not tear down. I think I'll make it a little bit smarter, which let me think. So one thing I can think of to improve this is to wait, why do I have client here? Weird. Okay. All right, I do need to have this. So one thing I think of is that is to not to not destroy the container, instead of just destroy the table and recreate it. But then we'll have to add some new logic to determine if this is the remote. So this is in running this in a pipeline or in a local environment. I will think about it. The creating the container takes a couple of seconds, which is annoying, but not entirely unacceptable. Anyways, I'll think about it and fix the repository issues I just found I forgot to deal with. Cool. Thank you everyone for watching, and see you next time. And a Happy New Year. Bye.